Let's say we're given this stoichiometry question in a chemistry exam. We could answer it in this way. We use proportion to calculate the number of moles of sulfur trioxide needed, and then we use a formula to convert this into its equivalent mass. Or we could answer the question with a single generic proportion method, such as the unit factor method. We give the question in equation format and we multiply that by a conversion factor, which is the proportional relationship between the given and required variables. Hello, I'm Angela Stott from the University of the Free State South Campus, and this is a short video abstract of my research paper about South African physical sciences teachers' use of formulae and proportion when answering reaction-based stoichiometry calculation questions, published in Chemistry Education, Research and Practice. In this paper, I show that South African physical science teachers, and probably also physical science teachers from other developing countries, greatly underutilize proportion. 13% of my 171 physical sciences teachers sample failed to recognize the need to use proportion in any of the 4 reaction-based stoichiometry questions that I used. 25% recognized this need consistently, and 62% recognized the need for proportion for some, but not all, of the questions. Further, I found that the discipline of writing down a formula and substituting values into it helped those that were less competent with proportion to get some process marks, but was otherwise of insignificant value to solution success. But let's get back to this question and these 2 solution strategies. This one, which uses a generic proportion method, makes no use of formulae, because while use of proportion is essential in reaction-based stoichiometry, use of formulae is not. According to the South African Curriculum and Policy Statement, CAPS, either of these methods should be acceptable. The problem is that the way marks are awarded in exams at present disadvantages a generic proportion method. South African marking guidelines and exam reports focus explicitly on formulae, but only implicitly on proportion. Might this be giving the wrong message about the relative importance of formulae and proportion in stoichiometry to South African learners and teachers? We know that in the developing world, teachers' subject matter knowledge tends to limit what they can teach. And their subject matter knowledge is even largely limited by what they believe that they are expected to teach, which tends to be teaching to the exam. So by measuring what teachers in such contexts know, we can deduce what they probably believe is important and what they probably teach their learners. That's why it's valuable to investigate the extent to which teachers recognize the need to use proportion in stoichiometry calculation questions, and also to what extent that and the extent to which they provide formulae and substitutions explicitly in their own solutions affects their stoichiometry solution success. Based on this research, I recommend firstly that stoichiometry teacher professional development opportunities in the developing world need to stress the value of proportion, and they need to develop teachers' competence with proportion. Introducing teachers to a generic proportion method, such as the unit factor method, might help direct stoichiometry focus where it belongs, to proportion, rather than to formulae. Secondly, examination marking guidelines need to be changed to allow for the use of a generic proportion method with no penalty for using such a method instead of one that uses formulae. The main message of this work is that stoichiometry is about proportion, and so proportion is what needs to be stressed in examinations, in teacher workshops, and in the classroom. Please read the full article and also share it and the video abstract. Find a link to the article below, as well as a link to the research page on my website, learnscience.co.za.